Okay.
Okay.
All right. So I'm sorry that I'm the only one who won't be speaking Bahasa here. So, I'm Ken Shaw. I'm the CTO with Broncos, which is a new company, a startup company here in Indonesia that is doing some kind of cool stuff with payment systems. So I'm just going to cover Go here real fast. I'm going to try to keep this sweet and short. And basically just cover the highlights of Go and why you should be using it. So Go is a statically compiled, highly performant type language with similar syntax to Java, C, or C++. So if you're familiar with those languages, it's very, very easy to shift over. It's expressive, concise, it's clean, and it's very efficient. It's kind of a weird hybrid between Python, Java, and C. It's kind of like the weird child between those three. The reason for that is because it's fully garbage collected, but it has syntax of a dynamic language, much like Python. But then it still has kind of the large, it kind of has like the low-level C aspect, meaning that it's like fully compiled, it's static, and it interfaces directly with the C API. If you're familiar with that. Go was designed at Google, and it was designed for building very, very big pieces of software on very, very big teams. So, large development teams spanning hundreds of people, multiple offices in multiple regions, and it works very well with that. And I'll give some demonstrations as why that is. It's unlike C or C++ or even Java. It has unbelievably fast build times due to the way that the package structures are laid out, which means that it takes less than a split second typically to build a full static binary. And I'm talking many hundreds of thousands of lines of code, and it takes only like a half second, maybe 2 seconds to build a binary for that. It's really easy to write and deploy tests, and I'll show some tests. And it's one of the nice aspects of it is that it's not quite at C performance in terms of like raw processing power, but it's 10 times faster than Java. It's 100,000 times faster than Ruby or PHP or any dynamic, non-static, non-compiled language. And that really is what's really great about it. And kind of the combination of all of those things with the fact that it has a very simple, easy to use syntax. It has very, very few keywords, which makes it a very simple language. One of the things that's most appealing to me is that it makes coding fun again, which is what I really like about it. So here's just a quick example of like the Go kind of environment. As you can see, it's much different than your Java or your C or your Python style programs. But you've got a main, you've got an entry point, and you've got basically a standard library which is addressed with these, i.e. here in this you've got format, which is the FMT, which is basically a standard package that's done. Go, for the most part, is really something that is designed and built by people that are comfortable with the command line. So here's the command line stuff to essentially build it, but it does integrate well with most of the IDEs that are out there. So VS Code, Eclipse, there's any of the IDEs out there today will more or less work with it off the shelf. So getting more into kind of like the features of Go and why you might want to choose to use it is that it's garbage collected, it's memory safe, it has a very strong expressive type syntax, it has quote unquote instant build times, it has CSP style concurrent programming. So similar to the coroutines that we just saw in Kotlin, you have basically what's called Go routines in Go. And it's, again, simple language, and it has type composition as opposed to object-oriented inheritance, but we can, I'll explain at the end why that's better. So this is basically an example of that, the syntax of the language. This is the standard Y Combinator function, if you're familiar with that. This does the Fibonacci or the Here's the second part, or the factorial of 10 numbers. And it's, if you're not familiar with what the Y Combinator thing is, it's basically any language that has a first class function has the ability to do recursion, even if it's not built into the language to do recursion. And this just demonstrates how you would do that. You essentially return a function of a, you return a functor, right? A functor returns a function. So it just demonstrates how everything in Go is a first-class citizen, and I just wanted to illustrate what the syntax looks like, and I don't want to necessarily get too far into this on what it is. So Go is very expressive, and it allows you to make very, very complex applications using some very, very terse syntax, which may or may not be appealing to you. So again, how you would run the application, you would just go do a Go build, and then you would run it the static binary. So one of the really great aspects about Go in general is not necessarily the language, it's not necessarily the runtime, it's really about the tooling that comes with Go. Go has probably the most amazing tooling around it because it's built by an extremely large development team at Google, which is they've got anything and everything to essentially work with Go code that are like command line tools that will allow you to work and do things. Anything from code generators, static analysis tools, testing, and the list goes on and on and on. If in your development environment, if anything like correctness is important to you, then Go should be your language of choice, because there's no better language that you can basically create a provably correct solution to a problem, if that matters in your development. When you're building financial systems, which is essentially what my entire career has been, provably correct matters a lot, right? And it's one of these things that makes it easy on an auditor, essentially. So just to give you a quick overview, because I'm just trying to go fast with this, is that you've got two commands here. You have go get, go install. This is all part of the standard Go toolchain, which will retrieve remote packages from somewhere on the internet, and then basically will build, compile, and install it. And again, assuming you have a fast internet connection, this kind of stuff would happen essentially instantly, within reason. So the other really strong features of Go in general is that it has a very, very simple to well-written, easy to understand standard library. This is just a very brief sampling and overview of the main packages that are included in the standard library. You've got I/O for input-output operations, SARCCOM, which is string convert. You've got HTTP package for dealing with HTTP services, encoding JSON, image encoding, cryptography, regular expressions. Anything and everything is in the standard library. It's more or less, functionally complete with like the Java standard library. Of course, the names are all different and it works differently, but it's pretty comprehensive. So, one of the other things about this, and I know that it was talking about the learning curve. I'm going to be very honest with you. Go is not a programming language that is really designed for a junior programmer that's like right out of college. I mean, they obviously can use it and they can learn it, but Go works so much differently than other programming languages that you might have learned in school from like your object-oriented stuff, that it has not a difficult learning curve, it's just a different type of programming in general. Any coder that knows how to write code can learn Go. It's just that it's a very different model in general, and if you're going to take advantage of Go, you have to like learn the quote-unquote Go way, and if you don't do things in the Go way, in the Go style, you're going to be very frustrated with it, because you're going to be fighting the tooling, you're going to be fighting the system, and it just won't be successful. So That said, Go is probably the fastest growing language by almost every single metric you could possibly throw at it in the last year and a half. Based on, questions, views, on Stack Overflow, various surveys done by O'Reilly and other, and other kind of like open source publications. And right now is like a kind of a golden age and a renaissance of just an amazing amount of code that's being put out there in Go. And it's every day there's more and more great, well-written, open source packages and libraries or tools for Go or in Go that are just really amazing. And there's a site, Golang Lives, which you can use basically to search for anything and everything. So, as a sales pitch, because again, I'm not really trying to sell the programming language itself, but I want to try to basically sell the reasons for why you would want to use Go. Go is really great at writing fast code fast. So if performance is an issue in your organization, as I'm sure maybe a lot of you who are programmers here at a lot of large companies that have many, many millions of users, if you've tried to write something in Java or you've tried to write something in C or C++, the amount of hoops that you kind of have to jump through to make that work at performance and at scale it's not that it's difficult or impossible, it just is very long and time consuming. Whereas with Go, you can hit the ground running very, very fast, essentially writing large distributed systems that basically are the highest performing systems that are out there. Go also really performs really well with unit testing and benchmarking. Like, it is a first-class concept in Go to do unit testing from the get-go, and there is a very, very specific way to do unit tests built into the primary Go tool, and it's very similar to the XUnit style of testing that you find with PHP unit or JUnit or any other XUnit style testing framework. That said, Go is also really, really great at handling things like back-end system services. So HTTP, RPC, microservices architectures, all of that kind of back-end application server aspects is really what Go accelerates at. I'm going to give some very minor code demonstrations of how that is, but it's more as an example and less about what it is, and less about showing what Go can actually do. The other thing is that what Go is really great at is that it's really easy for deployments. Because you get a single static binary, basically all your deployments end up being is copying a single file out somewhere to an image or a VM or something like that. Or you're building, and also because the build times are zero, you can update the code, build in line, restart a process, and you're talking a downtime of measured in milliseconds and not necessarily minutes or hours if you wanted to try to recompile a C++ program. The other thing is that because Go is binary compatible with the C ABIs, it is very easy and straightforward to integrate C or C++ packages. So the whole wealth of existing code that exists in C and C++ is very easy to use, and it's very common in a Go workflow to incorporate C or C++ libraries inside your code. Meaning, like, if you needed to do something like FFmpeg encoding, or you needed to re-encode an image, or integrate with the TensorFlow library or something like that, then it's very easy to do that directly through Go by accessing the C equivalent APIs. Okay, so just a real quick example. Let's say I have an arbitrary function for an example of unit testing. So this is just a simple function. Notice that it's fully typed end to end, and basically what all this function does is convert an integer to a float, right? Not very complex. So a unit test might look like something like this in Go. This has what's basically considered to be the quote-unquote standard, test tables at the top. And notice that like in a dynamic language, even though the top has been, even though the struct that's there has been typed, you don't actually then have to redeclare the types later on. And these constants get executed, or sorry, not executed, but they get evaluated at compile time with the actual type that was associated with it originally, right? It sounds complex, just understand that it's really got some great magic. And you see here also in the syntax is that you've got a range loop, so you've got kind of all the standard modern features that you would find in a dynamic, language, but at the low level, at the lowest like C level essentially, lowest compiled level, and you get all the same kind of functionality. So, anyways, so running a unit test is very, very similar and straightforward to running, to building or installing the application. You just do run go test, -v or whatever if you want verbose output, and you get output that runs like something like this. So notice the name of the test convert int. That maps directly to the function that was called. Go handles compiling all of this, running this, setting up your unit tests, executing it, and essentially doing the performance. Notice that, this was a trivial test, it doesn't really matter, but notice that the time that it took to compile, run it, and execute it, and all the tests took literally 1/10 of a second. 1/100th of a second, right? It's 0.001. That's the entire end-to-end time of compiling, building, running that unit test. And again, it's not exactly a complex unit test, but that's compared to if you're running a unit test in Java or PHP, where you'd have to like spin up the PHP unit, or you'd have to spin up JUnit or whatever it might be for whatever programming language. This is really, it matters, right? It matters because when you're running a large development team and you have unit tests set up, one of the biggest hurdles to getting your developers and a team to run the unit test is basically making it easy for them to do that. And by reducing the time it takes to run unit tests, developers will be more likely to do it. I mean, it's this strange concept, but it does work. The other thing that's really nice about this Go testing is that it handles code coverage, it handles benchmarking, it handles race detection. So you can basically test if there's any kind of like memory racing going on. If you're not familiar with what memory races are, it's way too much of a complex topic to get into, but you have all this kind of low-level memory protection that just doesn't exist in other programming languages. I don't know of any other programming language that at compile time has a race detector. So, whatever. All right, so this is another example, just to show you like the power real quick of how fast Go allows you to build very, very complex systems. So this is a very simple HTTP web server. All it does is check a query for, a query string on a web request. And notice though that I've got a let's encrypt auto cert, so auto certificate helper. So this right here will essentially, it's 6-7 lines of code, and it essentially allows you to start up a fully encrypted HTTPS server that's essentially unbelievably performant. This server itself would be able to handle, even on my, very, very cheap laptop, hundreds of thousands of requests per second, because it's not doing anything that's I/O intensive. It's just reading stuff off of the network and pushing code back onto the network. So you've got these very high-level standard library features in Go that allows you to rapidly build out really advanced features and concepts. So unlike while there are in Go advanced frameworks like Echo or HTTP server, like there are advanced frameworks in Go, you don't really fundamentally need them. Like they aren't really necessary because the standard library itself is so complete. That's, some people would agree or disagree, but it's, at the end of the day, you can get everything done with the standard library, typically in about the same amount of lines of code as it would take you to do it in like PHP using a framework, or using a framework in Java, or any of the other languages here today. So the other kind of one of the great things about Go, again, is about, because it's a static compiled application, there are no dependencies. So, and one of the other things is too, is that there's tooling already out there for you to embed static assets. So if you need to embed static HTML or static images or something like that into your application, you can do that and have Go serve it and just push it out and deploy. So keep in mind that because Go is a full end-to-end like system, and it has its own HTTP server, it has its own implementation of everything. You don't need things like Nginx anymore. You don't need to run like firewalls or stuff on top of this. Not that I'm advocating for not using things like firewalls or whatever. My point is that you don't need to set up complex like hierarchies of having like web services front ends of like Nginx running over here, and then, you know, having that proxy through, you know, some kind of like, you know, forward pipe or whatever to a separate, you know, process. No, it's one process that's running and handling everything. And the thing that's really great about that is that your server resource usage becomes almost nothing. You don't have, there's no great overhead on memory for this, because you're not running the JVM. You're not going to run Nginx. You're not going to run all of these things that other frameworks or other languages might require you to use. It's all static, it's all compiled, and it's all available right there at your fingertips. So this makes deployments freaking trivial. Like before when I was working with a bunch of like large Ruby or PHP apps or whatever, you know, using Chef to like build an image might take 20-30 minutes just to build the image before that image could get deployed properly. So now building an image with Go becomes almost unbelievably trivial, because you just embed the one executable that's, you know, maybe 20 megabytes on your image. I mean, that's it. Like, your images don't need to be 2 gigabytes. They don't need to be 4 gigabyte images running on the cloud. I don't know if you guys are running like, full Ubuntu server images or something like that, but I can speak for Broncos. Like, we have basically our images that we spin up based on a stripped down version of Ubuntu, and the entire deployment, including the entire operating system and all the kind of stuff that goes around that, including the binary for Go, is less than like essentially 50 megabytes. And so we build a single image, we push that out there, and it's very fast. So, and again, there's no binary dependencies. There's no JVM. You don't have to bring a JVM with you. Having worked on and on some super large applications, I've had so many configuration and deployment issues with JVM on its own that I could write a separate textbook on just how to deploy the JVM. I mean, if any of you are DevOps guys, you probably are familiar with the pain of, XMS underscore, whatever, blah, 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 right? And all those marvelous environment variables. All of that goes away with Go. That's also why it's called Go, because everything goes away. These are links. I realize they're not very helpful since you guys don't have the slides, but these slides are already available on my personal GitHub account for the under the Go Jakarta like meetup slide group thing or repository or whatever. So there's really great community out there forming around Go. Go is still kind of a new language. It's actually been around for about 10 years now, but it's still relatively new. The tutorials are still budding out there, but there's great community tutorials, written in Bahasa Indonesia. We've got a monthly meetup group. We actually have a meetup this next Thursday. It's going to be at Menara BTPN in Mega Kuningan at 7 p.m. next Thursday. Show up. There should be enough room for everyone, hopefully. We have an Indonesian Telegram group here. If you want to learn more about Go and track what's going on, there's a site called Golang Weekly that sends out a monthly email newsletter. Or sorry, not monthly, weekly newsletter. There's the awesome Go list, and kind of all of the other stuff. But if you guys really are interested in learning about writing high quality, performant systems in general, just read the Go source code. It's 100% open source. It's MIT. I don't know if it's Apache or MIT or it's Go license based or whatever. But it's so easy to modify and change things around that if you want to just figure things out, you can just put print line statements anywhere in the code of the actual core standard library, and it'll show you exactly what it's doing. It's not like you don't have to go recompile everything. It takes literally a split second. Every time you compile a Go binary, it recompiles the entire standard library for you, essentially. So the Go source code is super high quality. Super high quality. It's written by some of the best engineers on the planet. It's well documented. They have really great examples. Really check it out. So there's been a lot of really big projects that have been moving over to Go, and again, Go is really kind of fills more of the niche on the back end. It fills more of the ops side and not necessarily the dev side so much. So a lot of big tools that you guys might be using, Docker, Kubernetes, these are all written in Go. Also, there's a lot of other stuff out there. If you're, Terraform, Console, that's all in Go these days. Hugo, InfluxDB, and there's just, the list just goes on and on and on and on. So, where is Go used? Broncos, Kudo, Grab, Tokopedia, Snapcart, Traveloka. Basically, every company in Silicon Valley now is using Go. It is really fascinating to see how fast and how rapidly the entire dev community, especially on server ops and all of that stuff, has just basically switched entirely over to Go. You don't find, I can speak from personal knowledge and experience, but you do not find a Silicon Valley company today building a new large-scale infrastructure application that's not written in Go today. You just don't find that. It just doesn't happen. It is the highest, it is the most highly demanded skill set today. And so if you are, career-wise looking for that, I would highly suggest you look into it and getting into it. There's a lot more companies. There are too many to list. Indonesia, internationally, they're looking for remote developers all the time. So there you go. So let me, I know a lot of the other presentations have had comparative stuff, trying to do blah 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 and a summary. So let me explain why you should do your next project in Go. Go is on a rocket ship trajectory right now today. It is going to replace everything on the server side. It is going to replace Java. It is going to replace Kotlin and Scala. It's going to replace PHP. Because today, a lot of the reasons why frameworks like CodeIgniter and Symfony and all that stuff in the PHP world, or Play in Java and all this stuff exists, is because it was about serving websites. It's no longer about serving websites. The world has gone mobile. It's about basically serving APIs, and Go is the single best fit for that, okay? So, no, because you serve, I mean, even today, if you're primarily serving a website, you probably have AngularJS, or you've got TypeScript, or you've got React, or you've got something else, or you've got a mobile app that's in Swift, or it's in, Java, or whatever it might be. But on the back end, if you're going to build a new project, use Go. There's no reason not to. All right. So that's basically it. So Broncos is also hiring. We have our monthly Go meetup. So seriously, come check us out. It's fun. Yeah.
Okay.
Yeah.
Okay, thank you, Ken. You can give applause. So I think we'll be replaced in the back end by Go, yeah?